And the Cloud Architecture Summit continues. This is the breakout session for Influx Data, and let me reintroduce Tom Crow, Community Manager at Influx Data. Tom, welcome back.
Thanks for having me, Vance.
You know, we're really glad to have Tom with us this morning. He helps educate and communicate with the Influx Data Time Series community. He's an accomplished product and digital marketer and strategist, and he's going to walk us through the benefits of why your cloud architecture needs a time series platform. You know, cloud architecture can deliver performance and scale, as many of us know, but to lock in those benefits, companies are finding that they often need a bit more monitoring help, and modernizing that solution is what time series can help you do. It will deliver better on granularity, ingestion, queries, and other monitoring issues that might just help you fine-tune some of your cloud performance and even the expense that you spend to host and run your applications and data sets in the cloud. So with that, we're going to take a look at time series, how it's filling the gaps that many cloud adopters are running into, and the idea of being able to capture metrics and events generated by apps, containers, Kubernetes pods, and nodes. Let me just remind you before I hand it to Tom, you can download the slides, even get a host of white papers and other downloads. Just click any of the links under the view screen. They're all available for you right in the open without any extra registration. You did that to join us today. And to connect with Tom, which we always encourage folks to connect with our speakers, just type in the submit a question box. So with that, Tom, let me turn it back to you and tell us about why your cloud architecture needs a time series platform.
Perfect. Hello, everyone. And like Vance said, we're going to be talking about why your cloud architecture needs a time series platform. I think based on the fact that you're here, you've got cloud architecture in mind. You understand that the monolith on-prem applications are out the door. The monoliths are being broken down, and we're moving into an age of microservices where those legacy monitoring solutions we have just aren't cutting it anymore. We're replacing the legacy apps for a lot of reasons. You know, we're wanting usability, scalability, responsiveness. They need to adapt to mobile and IoT needs. So there's this urgency in developing new customer-facing apps, and almost every application, except for maybe back office apps, are being monitorized. There's several ways you can go about modernizing these apps. You can either get a low-code platform, something serverless, start building your own apps, or you can figure out pieces of technology yourself and start building from scratch and construct an app using microservices. No matter what kind of app you're building, when you're integrating DevOps, when you're moving over to Docker containers, or you're starting to streamline your infrastructure with Kubernetes, you're going to need better monitoring. What you're going to need to be monitoring are your DevOps tool chains, your containerized apps, the containers themselves, the Kubernetes clusters, every stage of that, the nodes, the pods, everything. Traditional and legacy monitoring solutions just aren't built for that, and they're not cutting it anymore. Just like you're building more modern apps, you need a more modern way to monitor. Everyone is adopting Kubernetes, and it's taking the place for orchestration of your cloud apps and cloud native apps. You can see by the sheer numbers here that adoption of Kubernetes is steadily on the incline. It's left its competition, other solutions like Cloud Foundry, in the dust. And now that we are all moving towards Kubernetes, we have that question: how do we put monitoring in place effectively so that you can scale, you can identify problems, you can find memory leaks and bottlenecks, and you can monitor everything else that goes into building and maintaining your modern application? Let's first look at why we even want to look at better monitoring, why we should care. One of the biggest things for a cloud app or cloud native app is that high uptime that we need. We need to keep these apps up and running. Legacy monitoring solutions can monitor at 10 to 15 seconds, whereas you may get into some users we've seen have refresh rates of 10 to 15 minutes. So a lot can happen in 10 to 15 seconds, much less 15 minutes. If you want to measure your uptime, you really need your application parameters to be much more granular than that. We've got an increase in complexity. Our ecosystems of microservices and microservices hosted cross-domain add a whole new level of complexity to the equation. As we've seen, everything is getting much more complex and convoluted, and legacy monitoring isn't designed to keep up with that. Lastly, we're looking at scale. These complex infrastructures create huge volumes of metrics and events. You can be ingesting millions of metrics at a second or sub-second level, and being able to ingest, query, visualize, and understand those metrics is a unique problem that we didn't have 5 or 10 years ago. Because of this need for granularity and scale and insight into complex modern apps, time series platforms have emerged. They can ingest data, they can process in real time, and give you access to all of your data on demand as you need it. One thing we're noticing is that there are new workloads for metrics and events. We're seeing an explosion of connected things that are tied to modern apps. Millions and millions of devices are out there right now creating metrics and events at the nanosecond level. Chances are, if you're like most of us, you've got one of these devices like an Apple Watch or a Fitbit on your arm right now that's collecting data every time you move. If your app is connected with any device or is transmitting or receiving any type of data, then your legacy monitoring probably isn't able to support it. If your app requires instrumentation of a DevOps toolchain, if you're monitoring things in the real world, again, your legacy options may not be able to support what you're doing. And it's not just the DevOps toolchain. When you look at any of the underlying cloud infrastructure and containers orchestrations like Kubernetes, then the amount of metrics that you need to monitor grows exponentially. And one thing we've learned is as developers are getting more data, they want more data. So that's just continuing, like I said, to grow exponentially. So what makes events and metrics unique? It's not that they're new. We've been collecting metrics and events for years and years and years. Metrics and events are all of our timestamp data. We can be generating those in regular intervals, like our metrics where we're pinging every few seconds, we're looking at what our CPU load is, or at irregular periods, like when we're collecting data when something in an app fails at an irregular time period. This is producing huge volumes of data, and that's what's new. The scale at which we're collecting information and the sheer volume of information and data that we're ingesting is huge. We're collecting tens or hundreds or even thousands of times the data that we were collecting previously. And that is what makes time series platform different. Time series platforms are built specifically to ingest large volumes of metrics and events. They're made to perform real-time queries of these large data sets, and they give you the option of rapid eviction and transformation of your data, the downsampling of high-precision data to save as you need, and then they're built for storage optimization and compression. Time series platforms put the spotlight on metrics and events. Time series data, like we said, isn't new, but the scale has come to a point where you need something to handle that. You need something to handle that high ingestion rate, that high query rate. You need something that can downsample and optimize your storage of this large data and compress it. Time series databases are growing much faster than other types of databases out there, like SQL databases, search, big data. And it's because of their ability to perform. They're outpacing everything, including like GraphDB, which is also really popular right now. And the reason is that time series platforms are able to solve that specific need where they can ingest large volumes of metrics per second. And they can go to the sub-second level and millisecond level and even nanosecond level. On top of the high volume of writes, they can also handle large numbers of simultaneous queries. So you can bring in all of this data, you can write all of it and query it in real time, and then you can get rid of large volumes of data that's not required anymore or downsample the precision, which is something that none of these other database offerings are built to do. Now that we understand a little bit more about time series data, we understand the need for a time series database platform, let's talk about InfluxDB. InfluxDB is a modern engine for metrics and events. It's designed specifically to be easy to start and easy to scale. It's built to instrument, observe, learn, and automate any system, application, and business process. For a high-level overview, InfluxDB is ideal for all of your metrics and events workflows. The data comes in from all of your data source, from your infrastructure metrics, your business metrics, your IoT or IIoT devices. It's processed and stored and used for monitoring, analytics, for tracing, and for machine learning. To look a little more granularly at how InfluxDB is built is built on what we call the TIC stack, which are 4 open source projects that we built here at Influx Data. The 4 components are Telegraph, InfluxDB, Chronograph, and Capacitor. Telegraph is our biggest and most popular open source project that we have. It's your agent for collecting and reporting metrics and events. So Telegraph is easy to get started with. We've got 200 plugins that you can start using right away. And if you have legacy software or legacy hardware that you need to monitor, you can build plugins pretty quickly and easily for that. All of your data from Telegraph typically comes into InfluxDB. It's the core of our stack. It's our storage component. It's that purpose-built time series database. Built into the tech stack as well as Chronograph. It's our interface for the InfluxDB platform. It's that configuration layer. It gives you visualization and pre-canned dashboards for things like Kubernetes. All aspects of your cloud architecture and infrastructure can be put into Chronograph and visualized. You can view these results and save them and share these views and dashboards with others within your team as well. And then we have Capacitor, which is the real-time streaming data processing engine. And that gives you the ability to monitor all the data that's streamed in from Telegraph. You can use pre-built functions that we have, or you can define your functions and bring over your functions from your legacy solutions that you have. And it integrates with any of the alerting frameworks out there like PagerDuty or Sensu. You can even set up a quick, easy plugin to send all the alerts that you're generating over to Slack. So let's look a little more closely at all of these. This is that Telegraph plugin. It has the concept of 4 distinct plugin types to collect and report metrics. We have input plugins, which are collecting metrics from the system, services, or third-party APIs. You can grab stuff from Kubernetes, from VMware, from Docker, from your networking devices, bare metal, or Prometheus endpoints, as well as old technology or new technology. And what it does is it scrapes those metrics from any technology and brings them into InfluxDB and Capacitor. The processor plugins transform, decorate, and or filter the metrics. So as it brings in that data, it can transform it or change it in any way that you need. You can set that up as it's coming in. It's got an aggregator plugin, which creates aggregate metrics. So as things are coming in, you can calculate like the minimum, the maximum, your quantiles. You can get the average or mean. And then output plugins, which do the same thing as the input plugins, but in reverse. They write metrics to various destinations. Then we've got our InfluxDB, the modern time series database. This is built from the ground up, specifically with time series data in mind. It's super performant data store for all metrics and events. Anything that comes in that's time-stamped from anywhere can get stored into InfluxDB. And then it'll conserve space on your machine by however you decide to configure it. You can keep data for a defined length of time. You can automatically expire data. You can delete any unwanted data from the system, or you can downsample data as you need it, depending on that granularity that you need to keep. One of the other great benefits is it uses a SQL-like query language for interacting with the data. Capacitor is our native data processing engine. Once the data is in InfluxDB, you want to do some real-time streaming and data processing, and that's where Capacitor will kick in. Like I said, you can bring in your own functions into Capacitor, or you can use the same logic on top of InfluxDB with Capacitor that you're using currently. It issues alerts in real times. It also has plugins that you can use to process alerts with dynamic thresholds. You can match metrics or patterns, compute statistical anomalies, or perform specific actions based on these alerts, like dynamic load rebalancing, or you can program it to start machine learning. You can get it to start alerting on those anomalies that it's detecting, things like that. Then we have Chronograph, which is that visualization layer. You can configure, you can set up dashboards and visualize all of your data. There's a built-in data explorer that lets you either write queries or you can do a query builder. There are templates and libraries, alerting and automation. It's really a great visual tool to help you look at your data, to help you query it and share with your team what information they may need. I know I mentioned earlier Kubernetes and Docker and other components of that cloud architecture that you're probably using when you build. InfluxDB fits in really nicely with those using Telegraph. This is an example of what that would look like with your Kubernetes and Docker deployment. You would deploy Telegraph as a daemon set for your Kubernetes node. And then for each of your pods, you would set up a Telegraph sidecar for the pods. This way you can get constant metrics out of Telegraph for the nodes and the pods to monitor both. And you can implement a push-style metrics for the whole cluster. Using InfluxDB to monitor your cluster, you're getting the consistency in all of your metrics. You have long-term storage and high availability options there, and you can enable push-style metrics. Here's another example of how InfluxDB can coexist. One of the questions we get all the time is, why would I want InfluxDB when I already have Prometheus? Since Prometheus comes pre-built with Kubernetes, users slowly learn that Prometheus has no long-term storage, no clustering, and no high availability. It's not really suitable for enterprise needs. What you can do is you can put in Telegraph and set it side by side with Prometheus. Prometheus is obviously good with Kubernetes. It gives you some of your data that you need, but InfluxDB works really well to give those enterprise-wide needs that you may have. You can pipe your Kubernetes data into Prometheus and then use Telegraph to monitor and scrape for Prometheus inputs. You can ingest that into InfluxDB with your non-Kubernetes data so that you're monitoring your full stack that you have built. This option really works best in two cases: when an InfluxDB customer is adopting Kubernetes, or when a customer is adopting InfluxDB and has Kubernetes at the same time. Basically, if you've invested a lot of time and energy and effort and money into using Prometheus, this is a really easy way to bring in InfluxDB without losing any of that. The investment's not a concern. It's still happening. One great example of how this is being used: Microsoft has deployed Telegraph, as Damon said, in over 500 of their nodes. We're going to go a little more in depth into that. I have Prometheus, why would I need InfluxDB question that we get asked. Even if you're building cloud architecture from the ground up right now, chances are there's still something that you have that you need to monitor that's not going to be within your Kubernetes architecture. InfluxDB's Telegraph agent will collect metrics and events and provide visibility across all aspects of your Kubernetes deployment, as well as your non-Kubernetes infrastructures. Cloud native is great, but you have to look at the whole situation that you're building on when you have cloud native and non-cloud native apps collecting metrics and events together. InfluxDB can bring clustering and high availability into the picture with our InfluxDB enterprise offering. It's an ideal solution for long-term storage and high availability to complement Prometheus' ephemeral storage. Since there's no dedicated organization to Prometheus, it lacks some of those security features you're going to need in your enterprise environment that InfluxDB can bring to the table. And since Prometheus only does pull with no push options, it's good for metrics. It's not going to be good for events. Enterprises have needs for advanced features like fine-grained security, real-time analytics, and alerting that just doesn't come natively with Prometheus. InfluxDB provides that perfect complementary stack to extend Prometheus. Again, as we said, it can handle both metrics and events. Since Prometheus is scraping or pulling metrics, it's not grabbing those events. And InfluxDB enables enterprises to monitor both metrics and events and blends them with the business context that's needed. Again, as we said, this will preserve your investment in Prometheus. You're not destroying anything that you've done. The InfluxDB stack can easily scrape those Prometheus endpoints and require no code change. So it's a new way to add monitoring capabilities without impacting existing functionality. So one great thing about having push as well as pull option with InfluxDB, let's say you're spinning up, your Kubernetes cluster is spinning up, it spins up 4 nodes, finds out quickly 2 of those nodes aren't being used and destroys them. And this happens within 30 seconds. Well, you're not going to get any insight into what happened, why that was done, or how those nodes performed with your legacy monitoring because of how quickly it happened, or even with your Prometheus instance. So InfluxDB gives you insight into things that happen really quickly, which we know happens all the time when you're building with cloud native architecture. So we recommend you activate your full stack monitoring with InfluxDB. InfluxDB works really well with Kubernetes. You can deploy Telegraph as a daemon set to start monitoring nodes, pods, and containers. You've got a service operator built in, which simplifies the deployment and backup of InfluxDB open source software using the kubectl commands. And it works really well with HashiCorp Terraform modules. They're available on AWS. Basically, if you want a single platform to get all of your metrics and events in and really see what's happening within your applications, you're going to need something to supplement Prometheus to deliver that. And InfluxDB can do that. It works with both Kubernetes and your non-Kubernetes sources to give you full stack monitoring. And with that, I hope that gives you a little bit of insight why you need a time series platform to monitor your cloud and cloud native apps. So that concludes my presentation. And with that, I'm going to turn it over to Vance.
Tom, thanks very much. A really great architecture look. That's what we have many here at Cloud Architecture Summit, of how you've reverse engineered really some great projects to bring together a portfolio for management and monitoring in this kind of very high speed, high volume cloud world. Thanks very much.
Thank you for having me. It was fun.
So Tom, as you might expect, we've got some big picture questions as well as a few that have to do with implementation, and let's get right to them. Tom, you mentioned a lot about the cloud era, that we've got high ingestion rates and query rates, and that we need tools to cope with all that. And the question here comes into, how does Influx Data time series correlate all that data from both our apps and the underlying cloud infrastructure into information people can understand?
So what we can do is we pull in all of that data using Telegraph. So you set up Telegraph on any system or any part of your app that you want to monitor, and that pulls all the data into InfluxDB. And from there, you can build any sort of queries that you want using Chronograph, make it super easy. You can find correlation that way between things and visualize it really quickly and easily in that Chronograph app.
Oh, fantastic. So just to drill down on that, for folks that are working on cloud native and DevOps in particular that have multiple updates a day, are there particular customers you're finding, Tom, that are using Influx Data to help them pinpoint their problems as quickly as possible?
Absolutely. One great customer we have is Wayfair, and they are using us for all of their backend for monitoring all of their systems and everything that they have running. Plus, they're using us on their front end, so they're measuring every aspect of their web apps. They're collecting over 20 million user metrics a day, and they're using it not only to monitor their website performance, their app performance, and their system performance, but also their business performance and health as well.
Oh, fantastic. Tom, it's been a great conversation so far. Just to level set the whole idea of cloud architecture, how does Influx Data work with the major cloud providers?
We've got a really quick and easy way to get started with InfluxDB 1.7 on Google Cloud and on AWS. You can do a one-click configure on Google Cloud Platform, for example, and you can click it to deploy within a container environment. It's completely free to deploy into your Kubernetes cluster. We're working on getting 2.0 out the door in general availability. Right now, you can test it out and play with it at influxdb.com/products. You can see InfluxDB Cloud 2.0 open source. Or you can try InfluxDB Cloud 2.0, which is our cloud offering that we host. And you can get started with that for free, just to give InfluxDB a try, start using it, testing it out, and seeing what you think.
Fantastic. Fantastic. Tom, one other topic, which is not so much on the technology side, but it's on the migration, not just of the software and the code, but of the people's mindset. I think a lot of people do have issues as they move to the cloud of just figuring out where the best place is to start, what data they need, what do they do with it once they get it, and create that nice virtuous cycle. Given your role as community manager, talk a little bit about how you're helping migrate people's way of thinking about embracing the cloud and using time series to do it better.
InfluxDB and all aspects of the TIC stack are open source projects. So they've been built alongside our community. We have a wonderful community that is contributing to the code. They're helping us build. They're giving us feedback, letting us know what they want, what works, what they'd like to see work a little better. And within that community, we have a lot of people who like to help others as well. So, for example, we've got our community forum, which is at community.influxdata.com. We've got our Slack, community Slack, which is bit.ly/influx-slack. And we've got a subreddit, which is the InfluxDB subreddit. All of those are great places that you can engage with and interact with influxers and people from within our community, so that you can learn how to get started with your native cloud architecture monitoring quickly and easily. And you're always going to find people in those that have done something similar to what you're trying to do, who are willing to give a hand and help out. It's a pretty exciting space. Also, if you're looking around to meet some more people using InfluxDB and time series data in your area, we have some great meetups, and also host Influx Days, 3 of them around the world. Our next one is coming up in San Francisco on October 2nd and 3rd. We'd love to have a chance to get to meet you and have you come join us at Influx Days.
Fantastic. Fantastic. I see time is just about up, Tom, but before you go, in addition to all these great community programs, I know you've got a lot of curated resources and assets that your team has shared with it. We have got a great list of it here in the breakout room under your view screen, but tell us how people could maybe take the next step and go more hands-on with InfluxDB. You talked a lot about the open source options. How would people get a hold of them and begin to maybe set up a sandbox or a trial?
The best way, I think, to get started with InfluxDB right now is to try out our InfluxDB Cloud 2.0. It's free to use. So the free version has a 72-hour retention policy that a paid version of Cloud doesn't have. But without needing to download and install everything. It's all built into that cloud environment that you can just click and get started right away. I did a workshop with some other Influxers last week in Minneapolis. And as I was doing the workshop, I was building the presentation for it to get people started. And literally it took me 3 minutes to get system data off of my computer into Influx Cloud and visualized in Chronograph. It was pretty amazing. That's really the best way to get an idea of how InfluxDB works and to start playing with it right away.
Fantastic, fantastic. Tom Crow, Community Manager at Influx Data. Thanks very much for a great look at how time series can really help speed up my migration and cut my errors as I go into a cloud architecture. This has been a fantastic session, and thanks again for the Q&A and the tip-off on how to get started.
Thanks so much for having us, Vance.
Our pleasure, our pleasure. And as Tom mentioned, and as I referred to, you see that big list of links that are underneath the view screen. One of them is Tom's slides. I highly recommend you take a look at that. A lot of information there. The other is some other curated assets, white papers, analyst reports that Tom and his team have graciously gave us that we can in turn give to you. No registration required there. Just click and they're yours. And a lot going on here in the time series space, as you can see, so couldn't fit everything here in this room. Here's a slide that'll take you some other assets on the Influx Data website. Download Tom's slides, and these links will be live. Thanks again, everyone.